So this question, let me read it for you so you can see where I got these definitions from. The question says a coin with a radius of 0.024 meters is dropped on edge on a horizontal surface. That's just saying it's falling on a flat surface. So the picture that I did for you on the handout, so this is example 2, it's something like this. So that's supposed to be a circle, and that's supposed to be a flat surface. So it lands here, and it starts rolling, and there's some key words that it gives in here. It gives you the initial angular speed of 18 radians per second. So that is my omega. It's giving my initial omega. In a straight line without slipping. Without slipping means that I'm not losing any of that rotation. So it is going to completely decelerate at this rate. So let's see, I'm going to call, if I call this direction positive, I need to use a different color. Let's just kind of write out what we have. If my omega is going that way, and I've defined that as positive, if it's slowing down, my alpha is going that away. My alpha is opposing my omega. This is just like velocity, right? If velocity and acceleration are in opposite directions, the thing is slowing down. So let's see, so I have an omega naught is my 18 radians per second. And I have, let's see, an omega final. So how far does it roll? Translation of that is when it stops. And it says in there before coming to rest. So our omega final is 0. And our alpha is 1.9 radians per second squared. So I don't know time, and I don't know theta. I am going to remind myself that I had a translation between theta and delta and x. Remember, we went around the circle, and so we defined that this arc length, this distance x, is just theta times r. So in other words, how many times this thing has gone around? Well, I can unroll this, and that entire distance that it covers is that unrolled circle. And that's what that is doing for me. So I can use these equations then, my kinematics. Let's see what we have. We have 2 omegas and an alpha. I don't have time. So I don't have time, that won't work. I have an omega final and an omega initial. I have an alpha. I can solve for theta this way. So let's use that one. So I can go omega final squared equals omega naught squared plus 2 alpha delta theta. Now I remind myself I forgot something over here because I have defined distances and what's positive. We're defined to the right as being positive. Omega is rolling that way, so that's a positive quantity, but alpha is going in the opposite direction, so alpha is negative. Another way to think of that is that I'm starting off with some initial rotational rate, right? And I'm going to lose that. It's slowing down. So the only way for it to slow down is to be subtracting this amount that it's accelerating over the amount of rotations that it has. So that's the piece I want. I know that I'm coming to a rest here. Rest, not a rest. So I'll have omega naught squared, moving this to the other side, divided by 2 alpha, so there's a negative sign, divided by negative 2 alpha because my alpha here is negative. So my negatives will cancel out, and that will give me a change in theta, or just the total amount of radians that I went through. So let's go ahead and write that in then. I have 18 squared divided by 2 times 1.9. And that gives me what? Let's see. 18 squared, what is it doing? 18 squared divided by 2, parentheses, 2 times 1.9. And that gives me 85.26 radians. And remember, we've defined, we said that x, so that total distance it's covered is just theta times r. So let's just remind ourselves that this has the 2 pi built into it. So I don't need to worry about that. So my theta times r then, so I have x equals 85.26. I don't know why that decimal keeps wanting to pop out, times the radius, so 0.024. So that final answer times 0.024 tells me that this thing went 2.0460. There's a 0 there. 046. Let me just rewrite that. 2.046. There we go. Meters. So what we don't know is what's slowing it down. This is probably some sort of friction. That's the thing that would make the most sense, right? So something is slowing it down, causing a acceleration in that rotation, and it is going to travel a total of 2.046 meters before it comes to a stop.